Well, hi, and welcome back to part 2 of functional groups. We left off talking about the first functional group of 6 that we're going to be learning about. The first one was the hydroxyl groups, and that was, just remember, a simple OH attached to a carbon, and that OH can honestly be attached to anywhere along the hydrocarbon chain. So it doesn't have to be at the end, it could be anywhere along one of those carbons, especially if you have a very long chain. You never, it depends on what structure you're talking about, that OH can actually pop up anywhere. So the second type of functional group that we're going to talk about, this will be number 2 under your outline. The second type of functional group is called a carbonyl group. Now carbonyl groups, there's 2 different flavors of carbonyl groups, if you will. A carbonyl group is honestly a double bond O attached to a carbon within the chain. Depending where that double bond O is attached, whether it's at the end or one of the carbons not at the end, we call it the middle, if you will, then they have different names. But let's first define what a carbonyl group is. It's a double bond oxygen attached to a carbon in a carbon chain. All right. So if the double bond oxygen is attached to the very first or the very last, one of the end carbons in a chain, that is called a aldehyde. So we're going to talk about that. So if the double bond O is attached to the carbon at the end of the chain, that is called an aldehyde. And if that double bond oxygen is attached to a carbon within the chain, so not at the beginning, not at the end, but somewhere within the middle, that double bond O is now called a ketone. So if the double bond oxygen is within, I'm going to say the middle, and by middle, I just mean it's not at the ends. It's within the middle. It's called a ketone. Oops. So you have aldehydes and you have ketones. And both of these are considered carbonyls. So let's see what that looks like. I'm going to erase this top part, but keep this part here for you. All right. Okay. So here's examples of 2 different kinds of carbonyls. The one at the end is called an aldehyde. Now remember, you have to have your double bond O. The reason I have another hydrogen here is because I need to complete the octet around the carbon. Remember, carbon yearns to have 8 electrons around it. So if I don't draw that hydrogen there, it's assumed it's there. However, I'm trying to be good at chemistry, so I'm going to make sure I complete my octet. So I have 2, 4, 6, 8 electrons surrounding my carbon. But since that double bond O is at the end of my chain, it could honestly have been here as well. Either carbon, the first one or the last one, they're the ends of the chain, that would be called an aldehyde. So if you were to label this one would be an aldehyde. Now this carbon, since it's not at the end, or I'm sorry, this double bond oxygen, since it's not at the end, it's on the second, or depending which way you're counting, this would be the first, second, third, this would be your ketone. So this guy is a ketone, okay? So you just gotta be watching out to make sure, am I talking about one at the end or one not at the end? And then they have different names. And truly, if you labeled them carbonyl, you're technically correct. But since you're on an honors biology class, let's up the game a little bit and try to get some specifics going on throughout this whole entire course. So that is the second functional group we got going on here. Let's move on to the third. The third functional group is a carboxylic acid, number 3. Carboxylic acid. So carboxylic acid looks kind of like a carbonyl group. It has a double bond O, but it's a carbon with a double bond O, and it also has an OH attached to that carbon. You will be finding these carboxylic acids at the ends of chains, just because that's all it completes the octet around the carbon, and they can't continue on a chain. You'll see what I'm talking about in a second. So this is when you have a carbon with a double bond O and an OH attached to it, and this carbon is attached to a chain somewhere. But this functional group is attached to the end of a carbon chain. So when you have a carbon, double bond O, OH attached at the end of a chain. Oops. At the end of a carbon chain. It would look something like this. So if you're looking at how the carbon, this carbon is attached to another carbon, so there's 2 electrons there. The double bond O is taking up another 4 electrons, and this OH is taking up 2 electrons. So I have 2, 4, 6, 8. The only place a carboxylic acid can exist on a hydrocarbon chain or on any carbon chain has to be at the end of a chain. So if you were to see a chain like this, and I would ask you label the functional group, you could circle this and say carboxylic acid, okay? If you're looking at it in shorthand form, this is where it gets kind of different looking. So if I have 4, I'll draw this exactly the same way, but in shorthand, I have 4 carbons, so 1, 2, 3, 4. I would have a double bond O and an OH coming off it like that. It's different, but you got to get used to it. You have to realize that this point where they're branching off, there's a carbon there, okay? And since I don't have any other atoms besides hydrogen on these 3 carbons, I don't have to put anything on it. But since there's something different on this last carbon, you have to tell me what atoms are on there, okay? All right, that's a carboxylic acid. The fourth one. The fourth one is an ester group, E-S-T-E-R, ester. Ester groups are interesting. I like those. I like them all. Ester groups. An ester is when you have your carbon and it's attached to a double bond oxygen and another oxygen. You're going to see how they're all very similar. So you got to decipher between your carbonyl, your carboxylic acid, and your esters. You get used to it. You just got to memorize how this nomenclature works. So this is when you have a carbon with a double bond O and an oxygen attached to a carbon in a carbon chain. And this can reside anywhere within the carbon chain. So a carbon, double bond O, attached to a carbon in the carbon chain. So I'm going to give you 2 examples of esters, one within the chain and one at the very ends of the chain. So okay, let's fill this in. Okay, there's actually, that's there. Okay, So this is a very different looking structure here. Automatically at the very beginning of this chain, you can see that you have double bond O and another oxygen. Since it's not an H, if this was an H, you would have said aldehyde. If this was an OH, C double bond oxygen OH, you would have said carboxylic acid. But since it's a C double bond OO, that's an ester. So you just got to get used to how these functional groups look and how to name them. Now traveling down this chain, you're going to realize you got your typical carbons with their hydrogens, that's cool. Then all of a sudden you have another C, a carbon, with a double bond O. But before you say ketone, because we've learned that one, right? But before you say ketone, look around the carbon. If there's an oxygen right next to it, you know you got yourself an ester. So this is an ester right there. And then the rest of it is just a regular hydrocarbon chain. So the neat thing about this ester that's in the middle of this chain, it's actually linking two hydrocarbon chains together. It's linking this section of the hydrocarbon chain with this section of the hydrocarbon chain. It's bringing them together. We actually call that an ester linkage. You don't necessarily need to know that level of nomenclature. Ester is perfectly fine, but in your minds, I want you to see how this becomes an ester linkage, because this is how things get made. You start linking things together to create these large molecules, and we're going to see that later on as well. So that is an ester linkage. This is just a regular old ester, which is lovely. We need to have these. So both of them are esters, and they're great. All right, now we have two more left, and then we'll move on to the next video. We're going to start talking about the different reactions that are going to take place. But before we do that, let's finish these last two. So number 5 is an amine group, A-M-I-N-E, amine. And now we're actually going to be getting into a couple of functional groups that use different elements besides carbon and oxygen and hydrogen. We're actually going to get into something else. So number 5 is an amine group. An amine group is when you have a nitrogen and two hydrogens attached to the end of a carbon chain. It's very simple. You'll recognize these fast. So it's when you have an NH2, basically, attached to the end of a carbon chain. Very easy to recognize. It's the only one with nitrogen. So that's in longhand form. And right away, you see that there's an amine group attached at the end. I could have put that on this side as well. Honestly, in space, this is rotating anyway, so it doesn't really matter. And since I have two carbons here, the shorthand for this is interesting. It's just a diagonal line like that. And then you put your NH2. That's a weird shorthand, but it's legit. All right. So now, the last one, and then we'll take a break from functional groups. Number 6 is a phosphate group. If you remember back in chemistry, you had your polyatomic ions. One of them was phosphate. If you remember what phosphate is, it's PO4 with a 3- charge on it. Now, in biology world, phosphates are covalently bonded to something else. When you create a covalent bond between an ionic compound and another compound, you typically lose one of those negative charges for each bond you make. So, in the biology world, phosphate has a -2 charge attached to it when it's covalently bonded to something. So, number 6. Lastly, is a phosphate group. Now remember, phosphate is PO4, and instead of being a 3- charge, it's going to be a 2- charge, and the structure is quite large when you think about all the other functional groups we've had. We've had little double bond O's and OH's and stuff like that. this is a 5-atom structure. It's starting to bulk up things a bit. And again, that leads to a different structure, which leads to a different function, which is all going to come into play. So phosphate looks like this. There's my phosphate and my phosphorus in the middle. And 2 of these oxygens are negatively charged. And that negative can bounce around and do whatever it needs to do, but it's going to stay within those 4 oxygens. So this is your big phosphate group, and it's going to be attached to one of the carbons in the carbon chain. So phosphate attached to a carbon in the chain. Bump into my structure. All right, so the way phosphate attaches within the carbon chain, it attaches through one of the oxygens. And the phosphorus is filled. It's actually one of the elements that can be overfilled. If you're counting around, you got 2, 4, 6, 8, 2, 4, 6, 8, 10 electrons surrounding that phosphorus. Phosphorus has that ability to break its octet rule. Not many elements can do that, but that's one of them that can, and it's for a good reason. But if you're looking at a typical carbon chain, you would see, make sure I draw a little lower so I can make room for that phosphate group. This big old phosphate group is going to be attached to a carbon, but it's usually attached, it is always attached through one of the oxygens, not the double bond oxygen. And honestly, this double bond can also travel around here as well. But then the rest of this is filled with hydrogens. So if I have 1, 2, 3, 4, 5 carbons in this example, I have 1, 2, 3, 4, 5 carbons in this example, and my phosphate group is branching off of this 4th in line carbon, I would do this. That would be the shorthand version of it. Okay, so just to recap everything we've done so far, we've talked about how important carbon is, and this is showing how flexible its structure is thanks to its tetravalency. We talked about 6 different functional groups. You have your hydroxyls, which is a simple OH. You've got your carbonyls, which is a double bond oxygen, and depending where it lies on the carbon chain, if it's at the end, you have an aldehyde. If it's in the middle, you have a ketone somewhere in the middle. Thirdly, you have a carboxylic acid. That's just a carbon with a double bond O and an OH attached to it. And then fourthly, what did we do after that one? We did our esters. And so esters were our carbons with our double bond oxygen and another oxygen attached to the same carbon. And those can be either at the end or in the middle again. Number 5, we had amines, which is just your nitrogen and 2 hydrogens attached to it. And lastly, we ended with phosphates. Now, come back for the next lesson. We're going to talk about 2 important reactions. One that builds up macromolecules and one that breaks them down. And then we could finally get into what these macromolecules are. So thank you for sticking with me through this brief organic chemistry introduction. And we're going to be on to the big stuff soon. So thank you, and I'll see you soon.